So welcome back to Next Gen Dev. In this video, we'll study about pointers in Golang. Before deep diving into pointer, we should know what happens at the backend whenever a variable is created. So whenever a variable is created, let us assume this is your memory. And whenever a variable is created, a dedicated space is given to that variable. And that space depends on the type of the variable. For example, if it is an integer, then a 4-bit space is given. If it is a character, then a 1-bit space is given. It depends on the type again. So let's do that. Let's create a variable here and the name would be num. And whenever this variable is created, Go runtime will allocate some space to it. So this is the value in that memory address, and this is the hexadecimal code like 0x8 or something like that. So this is what happens whenever a variable is created. Now let's create a copy of this variable. So this is a copy of this variable, and let's just rename this variable like num1, and it would store again num. So when this copy is created, it won't use the same address. It would use a different address because it is a completely different variable. So let's do that here. And its address would be again something else like 0x9. Just for reference, again, these addresses aren't contiguous. It is different because it is stored in a heap memory. Again, so whenever we perform any operation in num1, it won't affect num2 because these both are different address spaces. For example, if I like write here like num1 plus num1 plus plus, so it would change this address space because it is not connected to this address space because it is a complete different section of memory. So this is what was the basically concerning point for all the developers. Like we need a variable that could, store this, copy this variable, and also manipulate this variable. So this is what was the reason of creating pointers. So pointers basically store the address of these variables. So let me show you how it does. So what it does is that, okay, wait. So what it does that, let us assume this is the variable, and let's just copy it here. So this variable would just store address of the num1, which we already decided here. So, and whenever we create a pointer, we just add a star to the type. We'll get what are the basically structure of pointers. Just let's focus on the concept here. So it would show 0x8, whatever we have specified there. So whenever this variable is created, again, it will, the go runtime will allocate a different space to it. Like the value will be 0x8 because it is storing that address, and it will have its own address as well, like 0x6. Let's do that. Line it later. Yeah. So this is what happens whenever a pointer is created. Now, if we do this, like, let me just change the name here. Yeah. So when whatever operation will perform on this pointer will affect to this variable as well. So this is what pointer does. It stores the address of that variable. As you can see, it stores the address of this variable, not the value of this variable. Here we copied that variable. We did the same thing, but here we just stored the value of that variable, not the address. But in this, whenever we create a pointer, we store the address of that variable, as you can see here. And now if we just do ptr plus plus, then it would affect both. It would just look, okay, this is the address where I have to go. Then it would link to this. Then from here, it would link to this. Then it would increment this. So after this operation, this 5 will become 6. But after this operation, only this 5 will become 6. It won't affect this. So this is the basic concept of pointer. Let's go to our VS Code to see it more clearly. So whenever we create a pointer, we use a star symbol before its type. So first, let's create a variable like var_num, which we have discussed in the example, int, and assign it to 5. So this is a normal variable. Now let's create a pointer to this variable. So the pointer would be ptr again, and it would be of type again integer, but again we need to add a star to it. The star symbolizes, yeah, it is a pointer, and it would store the address of this variable. But how to get that address? So in programming language, if you want to get the address of a variable, you just have to use this ampersand sign or whatever you call and sign, anything. And then the name of the variable, it's num. So now this ptr will store the address of this variable. So let me show you that first. So print ln, and again let's print this ptr. Let's execute this. Let me clear my terminal. So as you can see, this is the hexadecimal code which I was talking about. So this variable was created, and this variable got assigned to some basically memory address similar to this, not this. Then this memory address was assigned to this pointer. So yeah, this is the memory address of this num. So now how to access this num variable? Okay, we got the pointer. So how to get the value of this pointer? So this part is called dereferencing a pointer. So dereferencing a pointer means that how to get the value from that address. So in order to do that, you just have to do this. You just have to add a star to it. So whenever you create a pointer, you just have to add star in front of the type. Whenever you want to get the value from that pointer, you just have to add star in front of the pointer. So let me show you that. As you can see, you got 5 here. The 5 represent this num variable. Again, in the example, as I have told you that we could create num1 again, and you could store this num. And again, let's perform both the operation that we discussed. So num1 plus plus and star. Again, to get the value, as I've told you, you just need to dereference it using a star ptr plus plus. Now if we print, let me just comment these out for now. Now if we just print num1, let's see what happens. So let's perform this operation first, not num1. Yeah, okay, it's not being used, that's why it's yelling at me. As you can see, num is not affected as we just copied the value, not the address. So now let's do this. Let's keep that as well. So now you can see that whenever we incremented the pointer, this value also get incremented because we are printing num here, not the PTR, as you can see that. And but when we did this, it didn't affect it this because it is not storing its address, it is just storing its value. So that's what pointer does. It stores the address and also manipulates whatever variable is there in that address. So this is what basic pointers look like. So call by value and call by reference are the two most common terms associated with pointers. Let us understand this with an example. So let's create two functions. One would be call by value, and this function would take a name of type string. It won't do anything. It will just update this name. And let's create another function, call by reference. And this function would again take a name of type string. But this type would be of pointer type. It would take a pointer to the string, not exactly the string. So now this will also update. So in order to access or dereference a pointer, as I have told you, you use the star thing, star, then the name of the variable. This is how you can dereference it. And then you could set whatever value you like. So now we have created a two function. In this function, we just accept parameter by its value. And in this function, we accept parameter by its reference. Now let's create again a variable of type string and just name it to Andrew for now. Now let's create a pointer to this variable. So, and you could use the shorthand way, and pointer takes the address of that variable. And to get the address, you need this and sign. I've already used pointer, I guess. Yeah. So let's make it pointer one there here. So now what you could do is you could call both the function, and then first let's create call by value function first. So we just need to pass the name here, and let's print name here. Let's see whether it changes the name or not. And let me comment this out as well. So it won't yell at me. Now let's run this file. As you can see, we have name Andrew here. We called this function call by value, which changes the name to Jake. But again, the still we are getting the name as Andrew. It is not updating. Why? Because whenever we call a function directly by its variable, it sends the copy of that variable instead of sending this variable. So this, whenever we calling this function with name, it is sending a copy of that name, which we have shown, which I have shown you earlier that how copy works. It just copies the value, not the address. So whatever operation will perform in this num1 won't affect num. That's called call by value. Now let's test call by reference. So yep, let's call by reference. And in this, we need to pass a pointer to the name. So ptr1. Now let's see what happens. Let me just clear my terminal. As you can see, you got Jake here because name was Andrew. Then we send the pointer to that variable, and this pointer was updated by dereferencing it. And this particular address got updated by the name Jake, and that's why we could see the changes reflected here. So this is the basic of pointer. You would see in the upcoming videos, you would see a lot of pointers used in different types like in structs or in slice or in maps. So pointers are most commonly used in any programming language. So this was the most important concept of this course. I hope you like it. Please do like and subscribe. Thank you for watching.